There was or there is. What?
There is,
Okay.
not past form, present form.
Still you have.
Yes, sir.
Okay. So what are the conclusions? For you?
Yes, sir.
What are the conclusions?
Yes, sir. First, let us go to 3B1.
3v1.
Sir, first 1B. Can you just tell me what it is? Means
First,
I just didn't understand because if there is an AC, then means it lights the lamp, but when there is a DC, means direct current, it doesn't.
hmm,
Is it because that? Let me annotate and show that. Not this one. This one. Yes. Means if there is an alternating current, then like this, we can just assume that the electricity is like this. It's alternating from here to here, here to here, here to here. So the north pole will move to this side and again to this side and again to this side. This moving causes the magnetic field to be cut by this coil even if it is not moving. Is this the reason, sir?
yes.
Okay, sir. I actually didn't wrote the answer because I was a bit confused.
Now you understood.
Yes, sir. So means it's
Yes.
two ways. So means then we will say that in B2 that uh, what do we say? If there is an alternating current, the moving of the poles uh, makes the movie means if the poles are moving, then the magnetic field as well. And while the magnetic field lines are moving, those are being cut by the coil, which will not happen when there is a direct current, as the magnetic field poles, magnetic pole will not move, so so the magnetic field lines.
Yes.
Okay, sir. Yes, sir. Now to 3D.
So 1A, the main idea is iron
It's
is
a
soft
soft
magnetic
magnetic
material.
material. So so it will not stay magneticness. It will not hold the
So it can be
magnetic.
used as temporary magnet.
Yes, sir. It is a temporary magnet, and so it will not become a permanent magnet, and so will it help to move the poles of the magnet.
Yes, we can alter the poles, right?
Yes, sir.
By using alternating current. Okay, now part A you write, huh? On your worksheet you write it. Quickly write. Let us finish
So I
one by
wrote
one.
it. Sir, is it okay?
Yeah, it's fine. I already heard what you said. Then B, go to B.
Sir, actually, you need to go to B.
Yes. Read the question and tell me the answers. Hmm. Kareem.
Yes, sir. When there is an alternating current, the primary, sorry, sir, current in the primary coil, the lamp is lit. When there is a direct current in the primary coil, the lamp is not lit. State two ways in which alternating current differ from a direct current.
What is the first one?
Yes, sir. Uh, Direct current is what do we say? They move in one direction, and the electrons always move in one direction, or the current move in one direction, but the current in alternating current reverse in means after a certain period of time, means periodically it reverses. Sir, so in one we will write DC is the flow of current in one direction, and in two AC is the flow of current. Uh, flow of current. Uh, the current in AC flows reverse. The flow of the current in AC reverses after a period of time.
Okay, so this one is actually one single difference. You have to tell another one.
So which one do I write, please? Just the direct one, or the I need to both like
Both you write. Both you write in the first point you write.
okay.
Then second one you.
DC is the low current in one direction where AC 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 current reverses current reverses Okay, sir. The second one actually I can't say because I don't know or I
Okay,
can't
second one,
guess.
I'm helping you. While you drew the AC generator graph, you saw one thing that the
Yes, sir.
EMF is sometime becoming zero,
Yes,
sometime it
sir.
is maximum, and it's increasing.
Sometimes it is minimum.
Yeah, sometimes it is minimum, sometimes it is maximum, and sometimes it is in between, right? The values are
So,
varying from
yes,
0
sir.
to maximum, again maximum to 0, again from 0 to maximum. This way it's going, isn't it?
Yes, sir.
So it has the AC has varying size or varying amplitude. AC has varying size.
AC has var- varying size of amplitude. Uh,
Now
amplitude.
it's clear to you.
Yes, sir.
So because of this, we are also having change in
So
magnetic.
through the amplitude, we are trying to say the amount of EMF, right?
Yes, yes, yes.
Okay, sir.
Done,
Mm,
right?
yes, sir. And in C, I know the answer. Sorry. B2, I know the answer. That when DC current is passed, passed
Yeah,
the
yeah. Now you say aluminium.
posterior. Yes, sir.
Aluminium. Tell me about aluminium.
Sir, this is not question 2. Okay, this is question 3. Okay, sir, it is a non-magnetic material.
Non-magnetic material. And iron.
It is a soft magnetic material. And for this one, we need a strong magnetic material because it need to hold the magnetic power or it will slowly or means, like current now current is being passed through it, so it is behaving like a magnet, and the moment we just move it, means move this one, the magnetic effect also goes away. So we always like need to keep the electric one with it, electric supply, and if we try to hold the, so there are many problems, so we don't use it as a magnet in this one.
Yeah, iron is a soft magnetic material. Huh?
It can't hold the magnetic effect.
So they are saying why the magnet is not made from. Here they are saying magnet, so it is permanent magnet, right?
Yes,
Steel
sir.
magnet, permanent magnet. So uh, why they are not giving iron here?
Sir, because it is a soft magnetic material, it cannot hold the magnetic effect longer.
Okay, correct. Next, continue, please.
Yes, sir, I have a problem here, sir.
Yeah, please read.
Yes, sir. In one experiment, the magnet in figure 3.1 is moved to the left and pass into the solenoid. The N pole of the magnet travels y to x at a constant speed as it moves. The ammeter shows a small current. Explain why there is a current in the solenoid when the magnet is moving. Okay, sir, I know the answer, but I just have one single problem that do we need to mention electrons? Means, do we need to like mention electrons that they get attracted through the magnetic field lines, so they move towards it like that? Or do we need to explain it in the terms of EMF? Means not electron,
Okay,
just
look,
EMF.
they are asking you very simply that why there is a current in the solenoid
Yes, sir.
when the magnet is moving. The magnet is moving, we are having induced EMF, right?
Yes, sir.
And if the magnet is moving, then there is induced EMF.
Yes, sir.
If there is induced EMF, there is current also. Okay, are you done with writing?
Okay, so magnetic flask has been cut. Uh, a small amount of induced EMF is produced. If there is means induced EMF or EMF, uh, if there is EMF, then there is current.
Yes, yes.
Sir, do I need to write this? Then will I get the mark? Means
Yes, yes.
if there is EMF, then there is current.
No, this one only you will not get marks. You have to mention after
Yes, sir.
after the discussion. You just mention it.
Yes, sir. Means I just mentioned that the magnet passes through the solenoid, or on that time a small amount of EMF is produced. Means after this, I just need to say that if there is EMF, then there is current.
Hmm. So before that, you say uh, that when the magnet moves, then magnetic field lines are cut by the solenoid.
Yes, sir.
Uh, Therefore, induced EMF is produced. Okay, that's it. And in addition, you can write
No, sir. There is 5 marks. Sorry, sir. Three
three
marks.
marks, 3 marks. So in addition, you write that point we normally give for, you say, I already told, right? As there is induced EMF, there is induced current in the solenoid. Okay?
Sir, instead of magnetic field lines or means magnetic field lines, can we just write flask? Means not even magnetic flask, only flask. Like the motion of the magnet makes the makes the magnetic flask cut by the. Instead of that, can we just write flask?
Yeah, flux means magnetic lines density, isn't it?
Yes, sir.
So you always think that way, huh?
So I just
Magnetic.
need to mention magnetic field lines.
Hmm.
Okay, sir.
So have you
Uh,
written?
yes, sir. I'm still writing. Been cut by been cut by the. Yes, sir. Done.
Then read this question and then solve. Try to solve.
Yes, sir.
Got it?
Yes, sir. Yes, sir.
Hmm.
Uh,
What is
I
your
got
answer?
the answers as well.
Sure,
Yes, sir.
please.
0.045 millivolt.
Wait. Let me check my answer. This is question number 3.
3B21.
3 B2.
Yes, sir.
Oh, so your potential divider difference is how much? Huh? Karim,
Yes, sir.
what is the value of potential difference?
Sir, this much.
0.54.
Sir, 0.054.
Okay, 0.054 millivolt.
Yes, sir. You can just scroll down a bit so that it can.
Yes, correct.
Yes,
Correct.
yes,
Then
sir. If you could
next.
just scroll down a bit, then it will come to its position.
Hmm. It's
It
okay,
would
no
look
problem.
good. Okay, sir. I'm again typing.
Then next.
I by V. Okay, sir. 1 minute. Uh,
Yeah, what is the value of charge? Karim? Hello, Karim. Karim.
yes, sir. I was typing for which the mic just turned off anyway, and I couldn't unmute.
So, what is the formula of charge? Is it
Is it d by t?
division or multiplication?
Sir, I guess multiplication.
So do that multiplication quickly. So finish multiplication, then tell me the answer. Quick. Yeah, Kareem, are you rewriting?
Okay, sir.
Now it's fine. (6.3 into 10 to the power minus 3). How? IT.
Sir, multiplied.
Anything else from your
Yes,
doubts?
sir.
From your
Yes, sir.
doubts?
C.
C.
So you just asked the one which I knew. Yes, sir.
Yeah, yeah. So you can you read C?
Yes, sir. Just one second. I just need to make few corrections. Sir, sir.
Yes.
If I write milliampere into second, then what will it be, miss? What will be the unit?
Which one?
So what will be its, oh, sorry, sir. How, uh, yes, sir. What will be its unit, means you need
Coulomb.
something.
Coulomb.
Yes,
If
sir.
you see what you did 0.045 multiplied 0.14, then it will be millicoulomb. Millicoulomb.
Ampere into time is equal to coulomb. Yes.
Yes. So it should be millicoulomb. Huh?
Yes, sir.
Then next, continue.
6.3 into 10 to the power minus 3 millicoulomb. 6.3 into 10 to the power minus 3 millicoulomb. Yes, sir. In a second experiment, speed of the end pole is greater than it is in the first experiment. It now takes only 0.070 second to travel from Y to X. A current in the same direction is shown on the ammeter. State and explain how the size of the current compares with the size of the current in the first experiment.
Yes. First experiment we had time 0.14 second, right?
Yes, sir.
But now the time became half.
Yes, sir. Half.
So what will happen?
The frequency will be half.
So
The frequency
size
will be
of the
half,
current
right, sir?
is same. Size of the
Yes,
current
sir.
is size of the current is
Same.
same. Why?
Size of the
They
current is
they
same
said they said
because
it's
be-
hey, listen. They said the speed of the end pole is greater than its speed in the first experiment. So if end pole has speed greater than the speed in the first experiment, then there will be more current because we know induced EMF for current depends on three things. Number
the
one
speed,
is
the magnetic field strength, and the number of coils.
yes. So you remembered it. Thank you. Now you understood the answer. What should be the answer?
Okay, so it will double.
Mm,
The size
Can
of the
our
current.
listen? Our size of the current will be more, right?
So
Why?
do we need to write more or means comparatively or relatively something like that?
They are saying it's like relating with the first one and is second experiment,
Uh,
right?
okay, sir. So we will say that the the size of the current will be more because the speed of the movement of magnet is increased. Right, sir?
Yes, I can say.
The the amount of the size of the current compared will be more,
Mm.
means not compared, will be more because the speed of the magnet increased.
Mm-hmm. Okay, then next. Yeah, continue, please. Read.
Yes, sir. I just have one more line, sir.
Yeah, read, please, loudly. The same quantity change.
Yes, sir.
Yeah.
The same quantity of charge passes through the coil in both the first and second experiment. Explain why this is the case.
Yeah. Why this happened? Uh,
The same quantity of charge, sir, because the speed of the charge increased while the same number of current was produced. Means it is like the quantity of the charge increased because the rate of the charge was being produced increased, but the same quantity of means the flow of current increased but the current was same. It is like voltage increased.
okay, done, right?
Sir, am I right?
Yes, very close.
So what should have been the answer?
So look here, we can, this can be many, right? Like you are taking it towards, then you can take it away. This is one, okay? Hello,
Yes,
this
sir.
is the first one. You can take away the steel magnet.
Yes, sir. Means there are two
Then
possibilities.
opposite. Then what can you do? You can reverse it. Here is you are keeping now North Pole, so here you bring South Pole. You alter the magnet's direction, right? Then you take South Pole towards the coil. Is it clear now?
Not yet, sir.
Like now here we have N pole.
Yes, sir.
So you are taking the North Pole towards the coil.
Yes, sir.
Now for the first experiment. But for second experiment, what we are doing, we are reversing
Yeah,
the, pole.
magnet.
The magnet is
It's
there,
the
but
pole of the magnet.
yeah, pole of the magnet we are reversing and taking the south pole towards the coil.
Yeah, there will be an.
Then you are getting also opposite direction, isn't it?
Yes, sir.
There are more two options. We are not discussing those now. We will
Sir,
discuss
so
it
I
later.
can just simply write that the voltage increased, not the amount of current.
Okay,
Sir,
done, done.
sir, so what shall I write? Like the voltage increased, but not the amount of current?
Which one? D.
No, sir. 2.
Okay,
C2.
this two.
Yes, sir.
Look here, we have double the time in the first experiment, right? In our
Yes, sir.
second experiment, we have half the time, but the amount of charge is same. Amount
Yes, sir.
of charge is same because IT. We are multiplying IT, isn't it, to get the charge. So
Yes, sir.
when the time is double, that time the current was half, right?
Yes, sir. Sir, so the current actually increased.
Yeah. So here when the time is less, that time the current will be increased. So the product of current and the time is the charge, is constant. Is it clear?
Okay, sir.
So this one is done, right? And D also you wrote.
Yes, sir.
D also you wrote.
Not actually, sir.
Why? Why not actually? Write first.
Step 2 ways in which the experiment shown in figure 3.1 can be used to produce a current in the solenoid that is in the opposite direction. Mm, Sir, by reversing the magnet and
First one you write that taking away the magnet from the coil. This one. The simple one write first.
Yes, sir, done.
Then second one you write altering the pole uh, or reversing the pole and taking the magnet south pole towards the coil.
Means altering the pole.
Yeah,
Yes, sir, done.
altering the pole and taking south pole towards the coil. You mention it. Otherwise, after 3 days, you will not understand. Not only we are thinking about the marks, also we are thinking about our notes. If the note is good, then we can revise good. Otherwise, I have to explain you again and again the same thing.
Yes, sir, done.
Then number 4.
Yes, sir. First three are done. One will be steel, the second will be silver, and the third will be iron.
Yeah, the second one is also iron.
But we can also
Magnetic
use silver.
spinning we did in topic 17. Huh? We need soft magnetic material for magnetic spinning.
Sir, we can also use silver.
No, no. We must have to use magnetic
Sir, you
material.
can find in the Google, they say that we can use it.
Google says it, but we don't accept it. In our Cambridge
Because of the
syllabus,
expense.
no. In our Cambridge syllabus, the one we are getting that is iron. Okay, because it's channeling the magnetic fields. The purpose of magnetic screening is here very specific. We are we are protecting the delicate electronic equipments from the external magnetic fields. So when there is uh, dealing with magnetic fields, there must be iron.
Iron.
That is soft magnetic material. Is it clear now?
Yes, sir.
Okay. Silver cannot do anything here. We are channeling the magnetic field lines over there, so we need
So
iron.
iron and steel is the answer.
No, the first one is steel, second one is iron, the third one is iron. This way.
Yes, sir. I just told the overall.
Okay. Then next.
Yes, sir. A transformer is a device used to raise or lower the voltage or current of a circuit.
Okay.
It took me a lot of time to think.
Then
Okay, sir.
next.
Yes, sir. This is a graph. An AC generator supplies an input voltage of
Yes,
220 volt.
you drew this graph yesterday, right?
Sir, just let me show it again.
You drew this graph yesterday.
Sir, it would be like this, right? And a continuous one.
Yes, correct.
Okay, sir, I'm correct.
Then next.
Yes, sir. The output voltage will be 11 volts. Vs by
11.
Ns is equal to P. Yes, sir, 11 volt.
Mm, correct. Then next.
Sir, then actually in most of them I have my doubts.
Yeah. What doubts? Tell me.
Like the C11, you just explain why there is a current in the ammeter, like
Yeah,
if there is EMF, there is current. So the current is read by the ammeter. I
yeah.
just got
You
your.
also add there. You were mentioning induced EMF. For that one, there is one mark. Then you write why this
There
induced
is.
EMF is produced.
Okay,
Because
so I will write like this.
magnetic field lines are cut by the solenoid.
Okay, so motion of the magnet makes the wire cut the magnetic. Sorry, sir. Makes the solenoid cut the magnetic field lines, producing an induced EMF. If there is EMF, there is current.
Okay.
Is it a correct answer?
So can you repeat what you said,
Yes, sir. Motion
please?
of magnet, then I give a comma.
Mm.
Cut the magnetic field lines by the solenoid, producing an induced EMF.
Mm. Correct,
If
correct.
there is
All,
EMF, there is current.
yes, yes. Your answer is completely correct. That's part two. Part two, tell
Yes,
me.
sir. Explain how the current in the ammeter opposes the change producing it.
So it is coming from Lenge's law, right?
Yes, sir.
So you get the explanation from there, then you write.
Explain how the current in the ammeter opposes the charge producing it. Hmm. Sir, I didn't understand the question.
You go to the note of Lenge's law, you'll understand it. The statement you got in Lenge's law,
Yes, sir.
that is this one. We are saying the same thing. The wording is different, but the same thing they are saying.
Sir, Lenge's law was given before Faraday's law, right?
No, no, it's given before AC generator.
Before AC generator, Lenge's law. Yes, sir, found it. Due to the motion of the magnet, South Pole, towards the coil, we get S4 at the right end of the coil due to induced current in the coil, which later produces N and S pole according right and between. Okay. Okay. S pole at the right end of the coil. Hence, the magnet will not allow any more for will be allowed anymore further towards the coil.
So if you understand that, you can explain it now.
Okay, so the ammeter is producing a tiny bit of current, which is, sir, can you move,
Ammeter
scroll
is
up a
not
bit?
producing any current. Ammeter is showing you the current. Ammeter
Okay,
never
so
produces
the
current.
flow, The flow of the current is like this, for which S pole comes here.
You
Sorry,
you don't
N
need
pole.
to, hey, you do not need to show the flow of current here. You just make the idea that if you are taking S pole towards the coil, then you are getting S pole left side of the coil, okay?
So, so a current is flowing through the solenoid, which is making this one the N pole and this one the S pole. As this is
Yes,
the S pole and this is also the S pole, they will get deflected.
yes, that's it. That one you write here. Then also
Okay, sir.
mention that the magnet is uh, brought towards the coil. That time it happens. But if you are taking the magnet away from the coil, it is opposite.
Then it will support.
Yeah, then your pole will reversed. Okay.
Okay, sir.
So when you are writing or you are saying, you should also mention the motion of the magnet, where it is. It is towards or away.
Yes, sir. Done.
Then this part,
Okay, the magnet stop when the S pole reaches the middle of the solenoid. The reading on the ammeter is observed when the magnet is moved to the left and at a constant speed that is less than its speed in C1. Where did the pencil go? Yeah. In C1, state two ways in which the reading on the ammeter differ from the reading observed in C1 as the magnet moves to the left.
so you see what they are saying. The magnet stops when the S pole reaches the
The
middle of the
solenoid.
solenoid. The reading
Yes,
on
sir.
the ammeter is observed when the magnet is moved to the left at a constant speed that is less than its speed in C1. So now the speed is less, isn't it? Speed
Yes, sir. So the
speed is
the
less.
amount
So the current will be
amount
now less.
less produced.
Yeah. And what you'll see, another thing you'll see that the current
Reading in the ammeter will be
is
less.
opposite direction or deflection of the needle in opposite direction. Is it clear?
Yes, sir.
So
So
write these 2 points.
less reading in ammeter,
Mm-hmm.
ammeter,
Mm-hmm.
uh, opposite direction of the needle,
Yes.
or the sign of the reading before inversed or changed, sir.
Yes.
Which one should I write? That uh,
It's okay. It's okay. You write deflection is opposite.
opposite direction of needle. Yes, sir.
So we have question number 5, question number 6. Okay, only these two. These two, did you try? Huh? Karim? Hello? Karim? Karim? Hello, Karim? Hmm?
Yes, sir.
Question number 5 and 6. Did you try them?
Yes, sir. I had a look at them.
Okay, now this is your homework. Okay, question number 5 and 6. You finish. You got all the ideas already. Now you can
Yes,
do
sir.
them. So Saturday we have class, and at the beginning of class we will
Sir,
solve this.
Saturday.
Yeah,
Sir,
uh,
what timing?
same timing, same. You already said yes. Again you are asking.
Sir, Saturday.
Thursday and Saturday, these 2 days.
Sir, wasn't it supposed to be Wednesday and Thursday?
No, no,
Wait,
no.
Saturday.
Saturday and Thursday.
Sir, I can do it on 9 to 10 because since what? Sir, can we just keep it on Wednesday and Thursday? Because on that time I have some other class. Actually, I didn't saw the Saturday.
So you check now.
Yes, sir, I just checked
Yes.
now.
Yeah, so you
So
why
can we just keep it
yes.
on Wednesday and Thursday because I have some else
Wednesday,
class on that
Thursday, there
timing.
is a big problem. If you do this, then the schedule will be blocked. This way we cannot do. Either you have to take Monday, Wednesday, or you have to take Thursday, Saturday.
So can't we take
Yeah,
between them?
because other batches are set in that way. So if I want to shift anyone, I have to
So
shift
you
that way.
are willing to change my batch timing.
Yes, yes. If you want to change, then you have to totally shift the batch timing. Okay, that is the problem.
Sir, then in Saturday, can we just start one means half an hour earlier? Then it would be easier.
Half an hour earlier means 8:30.
Yes, sir, 8:30.
Okay, 8:30 is better for you.
Yes, sir.
Okay,
Or
sometimes it
if you
may
want,
be sometimes it may be 5 to 10 minutes delayed, or maybe not
uh,
always, because I
sir,
have
sir, 9
I
is
have
okay, sir, no problem. I will just shift a bit of timing. 9 is okay. So from now on, Thursday and Saturday, 9 to
10:30
10:30. Okay, sir, final.
final, Thursday and Saturday. Okay, then
Yes,
Saturday
sir.
you have test on structured part, topic 22 and 23. This test is a bit bigger, huh?
Yes, sir.
Test will be bigger. There are 30 marks, so it will have more time in the test, and
Okay, sir.
you
Sir,
prepared, huh?
1 minute. Just 1 minute. I need to confirm one thing. Then it would be easier to set the time and be confirmed.
Yeah.
I will just take 1 minute.